Patty Simpson with Simpson Math. And in this video, we're going to look at the expected value of a game. So the expected value is just a weighted mean. It's just the average. So here we have a game where we are going to draw a marble from the bucket. If a red marble is drawn, the player is going to win $2. If a blue marble is drawn, the player wins $1. And if a green marble is drawn, the player doesn't win anything. We want to know what's the expected payout for the game. So in other words, if I'm running the booth that's where the players are coming up to me, on average, how much will I have to pay out? So the first thing we do when we're finding the expected value is we create a probability distribution. So we have to look at the possible outcomes here. And if we look at this game, the possible outcomes are, well, we could win $2, we could win $1, or we could win $0. So those are my random variable, those are the possible outcomes. I could $2 pay out, $1 pay out, or pay out nothing. Then I have to come up with the probability of each of those outcomes occurring. So next I'm going to come up with the probability of each of them. Well, just to help me know, in order to pay out $2, I have to draw a red. In order to pay out $1, they have to draw a blue. And to pay out 0 would be a green. So let's look and see what is the probability that a player gets a red. Well, it's one marble out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1 out of the 10 marbles is red. Or it's a 1/10 chance that they get the red. The blue, there are 2 out of the 10 marbles that are blue. And the green, well, the rest of them are green, so that makes 7 out of 10 that are green. By the way, when you make your probability distributions, your probabilities should always add up to be 1. So you can check to make sure that your probabilities are correct by making sure that it adds to 1. And here it does, 1 plus 2 plus 7 makes 10 over 10 is 1. Once I have my probability distribution created, now I'm just going to find the average. So I'm going to take each one of those outcomes and multiply them times their weight. This is just a weighted mean. Multiply your outcome times its weight. So 2 times 1/10. This outcome times its weight. This outcome times its weight. And then once I have those products, I'm just going to add them together to find that average. So here I have 2/10 plus 2/10 plus 0/10. Add that together and you have 4/10 or 40 cents. So on average, this payout from this game would be expected to be 40 cents. Then we can, from that, start deciding how much money we need to have on hand. So for instance, if I have 100 players come to my booth each day, so if 100 people play the game, I can expect, how much do I expect to pay out? How much do we expect to pay out? Well, if you're paying out 40 cents on average per player, notice I'm not paying any one player 40 cents. But on average, that's how much I'm going to be paying. So if some people make $2 and some people make $1 and then a bunch of people make $0, it will average together to be 40 cents. That's what I expect. So if 100 people play, then I would just do that 40 cents times the 100 people that are playing, which makes $40. I would expect to pay out $40. Let me make one little change to our problem. Here, I'm not making any money if I'm running this booth. So to help me make some money, I'm now going to charge the people who are playing the game. I'm going to charge them $1 to come play. So if the game costs $1 to play, everything else stays the same. And the game consists of drawing a marble from the bucket. They win $2 if if a red one is drawn, $1 if the blue one is drawn, and nothing if the green one is drawn. Well, they paid me $1. If they draw the red one, now I'm going to give them $2. But really, they're not winning $2. They're now only winning $1. So really, my red will just be $1. My blue is no longer $1. It's now $0. They paid me $1 to play, and I give them their $1 back. And then if they roll a green or they pull out a green, they're actually losing $1 because they paid me $1 to play. But I would find my expected value the exact same way. I would just take my outcomes and multiply them times the probability. Notice the probability here did not change because there's still the same number of marbles in each, in the bucket. So the probability remains the same. Now I do my multiplication and I get 1/10. This is 0. And I'm subtracting 7/10. So I have a negative 6/10. Or on average, I'm now going to make 60 cents. I'm going to have a negative 60-cent payout. I'm going to make 60 cents on average on each customer that comes out. So if 60 people, if 100 people come and play again, then how much do we expect to pay out? Well, we don't. In fact, I'm going to make $60. I'm going to not pay out. I'm going to get a negative $60 payout, so I'm going to make $60 on this game. So charging them $1 will help me to make some money on there. In fact, anything more than 40 cents, and I would have made money on it. If I had charged 40 cents, we would call that a fair game. It would come out even. I would break even at the end of the day. So here's an example of finding the expected value. Math Made Simple is some math. Thanks for watching.